This is the 5153 morning quiz review. Let's look at number 1 and 2 here. The directions for 1 and 2 says differentiate each function with respect to x. So let me go through this solution here. So if we're trying to differentiate with respect to x, the first thing we can do, especially if we're dealing with logs or natural log problems, we want to look to see if we can make the derivative process a little bit easier on us by looking to expand. So if we can expand expressions, especially ones that are involved that looks more complex, using either the power, product, or quotient property for logs, we can basically expand these expressions into smaller parts, and then the derivatives for each of the parts will be a lot easier to handle. So let's look to see if we can use some of the properties here. Property here we can use is power property. We know that ln of a to the n, any exponent we can bring down in front. This is nothing to do with derivatives. We're just using properties of natural log and log functions that's available to us. So we can bring the 2 down in front. So 2 ln of 2x squared over 4x to the 5th plus 1. Now we can also expand further, because ln of a over b is the same thing as ln of a minus ln of b. We can use quotient property. So quotient property, we can distribute the 2 through as well. So ln of 2x squared minus ln of 4x to the 5th plus 1. Now we can apply the derivatives for natural log. So the derivative for natural log is u prime over u. So this is the u value. So u prime is going to be 4x divided by 2x squared. Clean this up a little bit to be just 4 over x after multiplying the 2. And then here ln of u is u prime over u. So 4x to the 5th becomes 20x to the 4th. The 1 goes to 0. And then the u value is the exact copy of what we see here. And if we clean this up slightly a bit more, we can work our way down to 4 over x minus 40x to the 4th over 4x to the 5th plus 1. So that matches with our option C. Okay. All right, number 2 here. We have, again, natural log of an expression raised to an exponent. We can go through power property, so bring down the 5 ln of x squared over 3x to the 4th plus 4. Continue expanding by using quotient property. So ln of x squared minus 5 ln of 3x to the 4th plus 4. We're doing quotient property as well as distributing the 5 through. So remember, quotient property, ln of a over b is equal to ln of a minus ln of b. And the 5 gets distributed through. Once we have these terms expanded, then we can go through the derivative rule for natural log, which is u prime over u. So this is our u value, so u prime over u, so we get 2x over x squared. Another way that we can do this, we can continue to expand. What I did here was I brought the 2 down in front, make it 10 ln of x, and then the derivative of ln of x is just 1 over x, u prime over u. Now, if you wanted to go through the derivative rule at this point, you can. It will still give you the same result. X squared becomes 2x all over x squared. So 2x over x squared will reduce to be 2 over x times 5. It'll come out to be the same thing, 10 over x. All right. ln of u here is u prime over u. So u prime over u is 12x cubed. That's the derivative for 3x to the 4th. All over our u value. And then we simplify and we match our solution. Okay, the direction for number 3 is use log differentiation to differentiate each function with respect to x. So the idea with log differentiation is that we take the natural log of both sides, and then we go through implicit, and then we solve for dy dx. So let me walk through those 2 problems here. So number 3, to do log differentiation. Now, we only do log differentiation if there are no logs in the problem to begin with. We're introducing logs into the problem. If there's already logs inside the original problem, then we don't do log differentiation. We only apply that if we're told to do it, or we're going to see number 4, we're going to have to use log differentiation. But we only apply log differentiation when there are no logs to begin with in the problem. So let's look at number 3 here. Y is equal to the cube root of x to the 5th plus 2. So now we can take the natural log of both sides. So natural log of y is equal to the natural log of x to the 5th plus 2 raised to the 1/3. I'm going to bring this up as a rational exponent. Okay. Then we can go through expanding a bit more, so bring down the 1/3. Now we can apply the derivative rule. So the derivative rule for ln of y, you have to go through implicit because we have y's now mixed into the equation. So the derivative for ln of y is 1 over y, or in other words 1 over u times u prime. So 1 over y times dy dx. And the derivative for 1/3 natural log of x to the 5th plus 2, we can go through u prime over u, which is 5x to the 4th over x to the 5th plus 2. And now we have dy dx. We can now move the y back over to the right side and then replace y in terms of x, which is the original equation. And then there we have our answer. All right, number 4, this is important here. This is an instance where we have to go through implicit differentiation because we don't have a rule that will allow us to take the derivative of an expression that has a variable raised to another variable. So we want to find a way to bring that 2x down in front, and the way we do that is we introduce logs into the problem so that we can apply and we use the power property to bring that exponent down, which will thereby make it easier for us to use a derivative rule that's available to us. So we're going to introduce logs into the problem. So take the natural log of both sides. Okay. Now the exponent can now come down because that's the power property for logs. So once the 2x comes down, we can write it as, well, I think what I did here was I continue to think of this as the 5 and the x to the 2x as two separate expressions, and then I went through product property. So ln of 5 plus ln of x to the 2x. Okay. From here, we can bring the 2x down in front using log properties. Now it looks like everything is ready now for us to apply derivative rules. So ln of y becomes 1 over y times dy dx. ln of 5 is just a constant, so that goes 0. 2x times natural log of x. If we want to go through and find the derivative, notice these are two expressions with variables related to one another by multiplication, so we have to go through product rule. So f prime g plus f g prime. So f prime, 2x becomes 2, g is natural log of x, plus f is 2x, and then g prime, ln of x is 1 over x. Now we have our derivative. We simply now have to move the y over to the right side to isolate the dy dx by itself. And then once we have that, then replace y back in terms of the original equation. So our final derivative answer is 5x to the 2x times 2 ln of x plus 2.